All right, let's look at some more examples involving the mesh subject headings. The mesh subject headings are the medical subject headings by National Library of Medicine. This is the 2003 version. It is out of date and should not be used for clinical purposes. That's the required disclaimer. This is the actual text of the file. From the previous video, you can look at it. It consists of one or more words of description, followed by a semicolon, followed by one or more codes. The codes are separated from one another by a period. And so we can see body regions is A01, abdomen is a body region, it's A01.047, abdominal cavity is A01.047.025, and so forth and so on. It is clearly a tree structure. Such and such is part of such and such is part of such and such. It's a hierarchical tree organized listing. These are terms, obviously, that are used to code up medical records and articles, journals, things of that nature. Okay, in the previous thing, we discussed the program build. BasicMtreePrint.mps, and I'll run it through more. And what it did is it created a series of lines. It created text lines looking like these, and then it executed them using the execute command. And you can see what it has done. It has gone through the input text. It has separated out the parts, the code parts and the text parts, and it has created lines that would create global array elements with the, for example, A01 is body regions, A01, 047, next level in the tree, abdomen, and then abdominal cavity, then peritoneum and Douglas pouch, and so forth and so on. These were created as lines of text, as I said, but executed. Once they're executed, of course, it creates these elements in the database. So now we have a global array tree called mesh, and it looks like this. All right, next question. Can we print it? Yes, we can. We have a, I've got a program here, a very basic one. Whoops. Basic tree print. This one here, it goes through using the more familiar order command. And first of all, we set lev1 equal to empty. And then notice the two blanks, that means forever. We set lev1 equal to $order of up arrow mesh of lev1. Well, lev1 starts as an empty, so what we get back here is the first value at level 1, which will be A01, the code A01. However, as we do this over and over again, eventually lev1 will come back as empty, in which case we quit. That quit applies to the 4. It applies to the 4 on this, and that's the predominant 4. You see we have a number of blocks underneath. Once this 4 quits, everything else underneath it quits. Notice two blanks again. So if level 1 or lev1 is not blank, or excuse me, empty, if it's not empty, we execute the do, and the do invokes the block. And what do? We write out the value of lev1, which would be the code, a blank, and we write out the text stored there at lev1 and a new line. Then we go to lev2, set it equal to empty. And we find the first, for given lev1, we find the first value of lev2. Likewise, if it comes back empty, we quit and we revert back up to the previous higher do. Again, if it's empty, we quit. Otherwise, and notice again the two blanks, we enter the block. Now the block writes out, indenting to position number 5, question mark 5, to character position 5. We write out lev2, a blank, and the value stored. And we do the same thing for lev3, except now we indent 10. Otherwise, we do the same. lev4, if we get it, we indent 15. And we only go 4 levels deep. This is tedious. It's basically the same code over and over again as we go down level after level. Now, I don't know what the deepest level in the mesh headings is, but it is greater than 4. I'm sure of that. But does this work? Yes, it does work. So if we run that, and I'll run it through more so you can see it going by. That's what it looks like. You see A01, body regions, then you get 047, then indented from there as abdominal cavity, then indented from there as peritoneum and retroperitoneal space, and so forth and so on. It's a very nice hierarchical listing, but it only goes 4 levels deep. If there are more levels, forget about it. They're not going to show up. But we could extend it and make it deeper. Is there another way? Yes, there is another way. We have additional functions that were added later to mumps, which make it easier to deal with lower levels of the data. First of all, I've got a program here, adv. 2. For some reason, the simpler one is the second. And this gives you the basic idea. This uses the $query function. First of all, we set x equal to up arrow mesh, just plain old up arrow mesh, no parentheses or anything. It's text, it's string. And then forever, notice the 2 blanks, we do this. We set x equal to $query of x. What query does is it gets us the next value of the global array, or the next index of the global array in the database until eventually you get an empty string. So I will get the first key value, as it were, the up arrow mesh parenthesis A01. That's the first one to come back. And then the next one to come back will be A01, comma 047, I think it was, and so forth. We are going to go through the global array in alphabetical order, getting back the indices. If we get an empty, well, a break is how I use, that's my shortcut to exit a loop. It's not in the standard, but it does work. You can get an idea what it does. Otherwise, I print out x. X will be the value of the mesh index or key. I skip out to column 50 because they get kind of large. That may not even be enough. And I write out at x. Well, at x is what's in x, and that will be the text. Does this work? I hope so. AdvancedTree2.mps, and again, I'll run it through more. And you see it is. You can see, and again, it looks like a tree because you see the levels of indentation, body regions, abdomen, abdominal cavity, and so forth and so on. And we're getting pretty deep here. We got some wraparound down here because, as I said, skipping to column 50 is not really enough. So when we got down to this long thing, tooth socket, it wasn't room for it to fit on the line when I did $50. If you're past $50, mumps automatically moves to the next line and moves to position 50. So that could be fixed. Let's use a larger number. Let me just say 70. It was set to this number for an example that was going into a book. So now we run it again, and you see things are spread out further there, and we don't get that collision. But some of them get fairly lengthy, as you can see. Many levels of depth. This one right here is 1, 2, 3, 4, 5, 6, 7, 8, 9 levels of depth. Newer mesh headings may be even further. I don't know. We're just doing this as an example. Okay, well, that is the that's query. That's a usage of query. You can see what's coming back from query. Every time you invoke it, it's giving you the next set of indices from the database until it runs out of them for mesh. There may be other things in the database, but once it runs out of them for mesh, it gives you an empty string. And so you are traversing the database without the use of order, and you're doing it in an alphabetic sense. The things are coming out in the order in which they're stored. You see the A01s come out before the A02s, and the A02s come out before the A03s, and so forth and so on. It's a text alphabet. The keys are text alphabetized. The numbers are coming out, they're all 3-digit numbers, so they're coming out, they look like they're numeric order, but had they been varying length, it'd be an alphabetic sort on the numeric portion. But anyway, that's nice. Can we print it a little different, something neater? Yes. VI. Here's a different version. It doesn't look very different, but again, there's mesh. Set it into X. There's the query. If I run out of stuff, I break. That's technically not in the standard. I won't worry about it. Qlength gives me the number of subscripts in it. The number of subscripts in the array reference X. And what I do is I indent by that amount, I times 2. So basically, if there's one index in the mesh value that came back, it would be indexed to position 2 or 4 and so forth. So then I write out what's in X. At X gives me the text contents for that global array reference. I skip out to 50. I think we're going to make that 70. And then I write out the actual mesh codes. And we will run that and run it through more. And again, you're seeing here we have an indented tree. You can see it. And remember, each of these is only indented by 2. The first one was indented by 2. And then the second one, which had 2 levels, is indented by 4. The next one, which has 3 levels, is indented by 6, and so forth and so on. But again, you're seeing the tree-like structure. Body regions is at the highest level. When you're only indenting by 2, it's not quite as visible. You can change that, of course. And you can see that under body regions, we have abdomen. Abdomen has abdominal cavity. Abdominal cavity has peritoneum. Peritoneum has Douglas pouch. Mesentery, which has mesocolon, and so forth and so on as we go down. And these are the global array references to these text topics. Okay, that is enough for now.